Okay, Assalamualaikum and hi everyone. Today we will present about our assignment on the subject Engineering Statistics, section 35 on the Lajak Cruise tablet J. So our group consists of 4 members, which is Anissa, Muaz Mardi, me, Muhammad Zuliman and Sivan Ashwaran. Okay, so our group already given the task to monitoring the quality of tablet production for a particular type of Lajak cruise for tablet J. We are required to present a report to the Lajak cruise top management, and the report are based on the sample data collected from the production of the tablet in December 2020, and it will be used to determine the tablet's uniformity at the every batch produced so that the further corrective measure can be taken if it is out of shape. So I will present for the first part, which is part A. So for the first part, and we have to summarize the data according to the task given, and then present in the three type of the presentation, which is a numerical method, tabular method, and then the graphical presentation. So for the first part is a numerical method. So our group divide it into three, which is a weight, relative density, and then tensile strength. Okay, so we come up with the all value that are crucial for the further calculation. So this is for weight. This maximum, minimum, mean, median, variance, and standard deviation is also same, which is same to the relative density, which is total, maximum, minimum, mean, median, variance, and standard deviation. So to the next part, which is tabular method. In the tabular method, which we take the shift as the our main classify, which is evening, morning, and night. So we got the sum, weight, average weight, var, variance, standard deviation, and then the count of weight. Actually, we divide it into three also, which is weight, and then relative density, and the last one is tensile strength. So as you can see is we divide into three also, which is evening, morning, and night, and this also evening, morning, night. So we divide into the five column, which is sum, average, variance, standard deviation, and then count relative. And then the last part is a graphical presentation. So after we divide into the three crucial part, and then we make a table to show that how the summarize of the our data. So as you can see is this one is for the weight of the tablet produced, and then the second one is the relative density of the tablet produced, and the last one is the tensile strength of the tablet produced.
Okay, I will explain about the part B. As we can see from the left side, we got the data given. We using a pivot table to get this table, and this is the frequency. So the total is 200. The total sample size is 200, same. And this we proceed from this table. We proceed to the graph, and we got this graph. Moving to the next slide. We using chi-square test for normal distribution, and we use the equation z in this column of probability in terms of z, and this column is frequency, and this one is the probability value. Moving on to the next slide, this one is the probability value, and the right side is the frequency and the expected value. We got the expected value from n times pi, where the n is 200 and pi we get from this value. And because the last variable is less than 5, so we substitute to both column. We do the same for the expected value, so we got this new table. This one is still the frequency, and this one is still the expected value, and the last one is chi-test. We use this equation for finding the chi-test, and this is the value. And below we got the total for chi-test. Moving to the next slide, compare the chi-test with chi-square test with chi-test significant with V, where the V is K minus P minus 1, where the K is number of the final variable. From the last table, we got the variable total is 6, so we put 6 and the P is 0, so 6 minus 0 minus 1 is 5. And then we put all to this one, and then we get this value. So
chi-square test is less than the chi-square significant B, or we got it 2.1845, so we do not reject the H0.
Assalamualaikum, my name is Maz Magdi, and I'll be moving on with the presentation on part C, which wants us to comment whether there is any significant difference between tablet weights from different shifts or not. We will use the one-way ANOVA table or the ANOVA single factor to evaluate or detect any difference from the different shifts. Before we conclude our test, we must rearrange the values of weight in terms of shifts, morning, evening, and night. This is how they look after the rearrangement. After that, we conclude our test, and here is the table summary with the default value of alpha, which is 0.05. From the table, we get the value F calculated, P value, and F critical value. P value is a probability of F calculated greater than or equal to F critical value. Furthermore, the hypothesis statement states that all the means are equal, whereas H1 states that at least one of the means is different and how to detect the difference if it exists. One of two conditions that must be met: if the P value is greater than alpha, or the F calculated value is greater than the F theoretical value, which when one of them are met, we reject H null. Otherwise, we fail to reject H null. From the ANOVA table, we notice that the F value, which is 1.160264, is smaller than the F critical value, 3.041753, and the P value is as well greater than the value of alpha. Hence, we fail to reject H null. In conclusion, there is no significant difference at the 5% level of significance, and we fail to reject the hypothesis statement H null because the P value is smaller than the value of alpha, and the calculated F value is as well lower than the critical F value. And that's all from me for part C. Moving on with part D.
Hello, my name is Sivanesha, and I would like to discuss about my part, which is part D. From the question, we get the data with 200 observation. We did a summary output from Excel using regression statistic, where we get the multiple R, which is 0.864435328. And next, this is the second table, where we get the significance F value, which is 4.81157 exponent negative 61. And next, this is the third table, where we get the coefficients of intercept and coefficients of relative density. So for my part of questions, I had to use the equation, which is straight line equation, which is y equals to mx plus c. From the third table, I get the gradient m, which is the coefficient of relative density, and the intercept y intercept, which is coefficient of intercept. By getting the m and c, I replace the value in the equation to get the straight line equation, which is y equals to 0.085373412 x minus 0.412989293. And next, I had to predict the tensile strength, where for the relative density of 68%, 74.3%, and 80.1%. By substituting the x value, I get the tensile strength for each relative density, which is these three values. And for the conclusion, the correlation coefficient R is equals to 0.86444, indicated the correlation between x and y, which is relative density and tensile strength, is included in the strong category. And next, significance F equals to 4.81157 exponent negative 61 is smaller than alpha 0.05, indicated there is a significance effect between x and y, which are relative density and tensile strength. Lastly, regression model used for the prediction of tensile strength based on the relative density is valid, while on CI 95%. That's all from our group. Thank you.